Section 1. The unseen foundation beyond code and capital. Many believe software success comes from brilliant coding, others think it is purely about having enough money. While good code and adequate resources are important, they are not the whole story. A deeper element often dictates the long-term fate of a software product. This element is architectural thinking. It is the art and science of designing the fundamental structure of a software system. Without this strong foundation, even the most innovative ideas can crumble under their own weight. Architectural thinking means looking beyond immediate features. It involves considering how different parts of the system will fit together. It also thinks about how the system will grow and change over time. This foresight is crucial. It helps in avoiding costly mistakes later on. A system built with poor architecture might work initially. However, it will soon become difficult to modify or scale. Consider a physical building. No one would start constructing a skyscraper without detailed architectural plans. The same principle applies to software. A well-designed software architecture provides a roadmap. It ensures that everyone is building towards a common, coherent vision. Section 2. Why architecture matters, the startup imperative. Startups operate in a highly volatile environment. Markets change rapidly, customer needs evolve quickly, competition is often fierce. In such a fast-paced world, the ability to adapt is paramount for survival and success. This is precisely where a solid technical architecture proves its immense worth. It provides the stability and flexibility that startups desperately need. Without it, a startup can find itself unable to pivot or respond to new opportunities effectively. A good architecture allows for rapid iteration. Startups frequently need to release new features or modify existing ones based on user feedback. If the system is well architected, these changes can be made with relative ease. Developers can add or alter components without breaking other parts of the system. This agility is a significant competitive advantage. It enables startups to learn faster and deliver value to their customers more quickly. Conversely, poor architecture makes every change slow, risky, and expensive. Consider the financial implications for a startup. Resources are usually limited. Every rupee spent must deliver maximum impact. A poorly architected system leads to technical debt. This debt accumulates over time, making maintenance and further development increasingly costly. Section 3. The architect's compass, guiding technical decisions. The role of a software architect is often misunderstood. Some see architects as disconnected from the daily grind of coding. Others might think they only draw diagrams. However, a good software architect is a vital technical leader. They are the guiding force behind the technical strategy of a product. Their primary responsibility is to define and maintain the integrity of the software architecture. This involves making critical decisions that have a long-lasting impact on the system and the team. An architect must possess a deep understanding of technology, but technical knowledge alone is not sufficient. They also need strong analytical and communication skills. They must be able to understand business requirements and translate them into a viable technical vision. They need to communicate this vision clearly to the development team and other stakeholders. This ensures everyone is aligned and working towards the same architectural goals. The software architect acts as a bridge between different worlds. They connect the business domain with the technical implementation. They balance short-term needs with long-term strategic objectives. Section 4. More than blueprints. An architect's key responsibilities. A software architect's responsibilities extend far beyond just creating initial design documents. One of their primary duties is to define the architectural patterns and styles that will be used. This involves selecting the right set of high-level structures for the system. For example, they might choose a microservices architecture for scalability, or a layered architecture for separation of concerns. This decision sets the foundation upon which the entire system will be built and directly impacts future development. Another key responsibility is managing non-functional requirements, often called quality attributes. These include performance, security, reliability, usability, and maintainability. The architect must ensure these aspects are designed into the system from the beginning. It is not something that can be easily added later. For instance, if a system needs to handle thousands of concurrent users, the architecture must be designed for such high performance from day one. This requires careful planning and technology choices. Architects are also deeply involved in technology selection. They evaluate different tools, frameworks, and platforms. They choose the ones that best fit the project's needs and constraints. This requires staying updated with the latest technology trends. Section 5. The MVP voyage, idea to initial product. The journey from a raw idea to a minimum viable product, or MVP, is a critical phase for any startup. An MVP is not just a half-baked product, it is the smallest version of a new product that allows a team to collect the maximum amount of validated learning about customers with the least effort. The software architect plays a significant role in shaping the MVP. They help define what is technically feasible within the given time and resource constraints, ensuring the core value proposition is delivered. The process usually starts with clearly defining the problem the product aims to solve. Then, the team identifies the core features that are absolutely essential to solve that problem for early adopters. The architect helps in translating these features into a simple yet robust technical design. The focus is on speed and learning, not on building a perfect feature-complete system. This requires making smart trade-offs. For example, one might choose a simpler technology stack for the MVP to accelerate development. Once the core features and scope are defined, the architect outlines a lean architecture for the MVP. This architecture should be flexible enough to allow for future iteration and pivots based on user feedback. Section 6. Crafting a lean MVP best practices for early success. Building a successful minimum viable product requires adherence to certain best practices. Firstly, focus relentlessly on the core value proposition. What is the single most important problem your product solves for your target users? The MVP should deliver this core value exceptionally well. Avoid the temptation to add too many features, often called feature creep. Each additional feature adds complexity and time to development, diluting the purpose of the MVP, which is quick validation and learning. Secondly, prioritize user feedback above all else. The primary goal of an MVP is to learn. This means getting the product in front of real users early and often. Actively solicit feedback through user interviews, surveys, and analytics. Be prepared to listen to harsh truths. The architect should ensure the system allows for easy collection of usage data and feedback. This data-driven approach is crucial for making informed decisions about future product development and iterations needed. Thirdly, embrace simplicity in design and technology. For an MVP, choose technologies that allow for rapid development and deployment. Section 7. The perils of neglect, common causes of product failure. Many promising software products unfortunately fail to achieve success. While market fit and business strategy play significant roles, technical issues stemming from poor architecture are common culprits. One major reason for failure is the accumulation of technical debt. This happens when teams take shortcuts or make suboptimal design choices to meet tight deadlines. Initially, this might seem to accelerate development. However, over time, this debt makes the system incredibly hard to change and maintain. Another frequent cause of failure is the inability to scale. A product might work well with a small number of users during early testing. But as the user base grows, performance degrades and the system becomes unstable. This often happens because scalability was not considered during the initial architectural design. Retrofitting scalability into a poorly designed system is extremely difficult and expensive. Users have low tolerance for slow or unreliable products, and they will quickly abandon them for better alternatives. Poor user experience, often linked to architectural flaws, can also doom a product. Section 8. Built to grow. Engineering for scalability and maintenance. Creating software that can grow with user demand and remain easy to maintain is a hallmark of good engineering. Scalability refers to a system's ability to handle an increasing amount of work. This could mean more users, more data, or more transactions. A scalable architecture is designed to accommodate this growth efficiently. One common approach is horizontal scaling, where more machines are added to distribute the load. Cloud platforms like AWS or Azure provide excellent support for this. Consider Netflix, a prime example of a scalable system. They use a microservices architecture. Each small service handles a specific function and can be scaled independently. If the recommendation service experiences high load, Netflix can allocate more resources just to that service, without affecting others. This architectural choice allows them to serve millions of users globally with high availability. The architect must choose patterns like microservices, load balancing, and asynchronous processing to achieve such scalability from the outset. Maintainability is equally important. It refers to the ease with which a software system can be modified, corrected, and enhanced. Section 9. The enduring blueprint. Architecture as a legacy. In conclusion, the success of a software product is deeply intertwined with the quality of its architecture. It is not merely about writing functional code or having a brilliant idea. It is about laying a strong, thoughtful foundation that can support the product's evolution over time. Good software architecture acts as an enabling force. It allows startups to navigate the turbulent waters of fast-paced markets with agility and confidence. It is the secret ingredient that transforms a visionary concept into a tangible, scalable, and successful reality. The software architect is the custodian of this crucial foundation. Their role involves much more than just initial design. They make critical technical decisions, manage non-functional requirements, guide the development team, and plan for future growth.